Hey everyone, Mr. Fugay here, and this video we are going to talk about how to construct angle bisectors, medians, and altitudes on the coordinate plane, and we will be using the Desmos geometry tool for this. So prior to opening this video up, make sure that you've had the opportunity to open up the 3.5 notes example 1 link from your notes, which will bring you to the exact same drawing that we have here. So with that being said, let's go ahead and start talking about how we can construct this. So we're going to start with angle bisector first. And by definition, that is a line formed that bisects each angle of the triangle. So we will have 3 of them. So to do that first, let's go ahead and actually find these angles first. So to do that, we're going to go up to the angle tool and select angle. Now the way that you will do this is, for example, if we want to measure angle B, that's actually called angle A, B. Oops. You can always control Z if you make a mistake. A, B, C, and it will measure that angle. Then we will do B, C, A to measure this angle, and then lastly we'll measure angle C, A, B. So now we have all of the angles of the triangle. This will allow Desmos now to actually create the bisector for us. So to do that, we're going to go to the segment tool here, the third one over, and choose angle bisector. And this is the easiest one because all you have to do is hover your mouse over the angle and click. Hover over the angle and click, and finally hover over the angle and click. Now, one thing we're going to do throughout this video is, so that this doesn't get confusing, is we're going to move these tools or move these segments over into our folders so that we can hide them when we go through each one. So to do that, the easiest way is to select each segment and then click on these 3 dots and hit move to expression list, and you'll see it pops over there. And we're going to do that for all of them. So here's my second one, 3 dots, move, and lastly 3 dots and move. Now I can take these and drag them into my angle bisector folder, just like so. And then the last thing I need to do is actually plot the point of concurrency. So we'll take the point and we will go ahead and click on that. One thing I'm also going to do is label this. So we're going to go ahead and click on that, and we're going to do 2 things. One, we're going to go ahead and move it over to our expressions list. And then the other point we're going to do here is click on label, so this check right here, and we're going to type angle bisector. And that is going to tell me that that is the intersection of the angle bisector. So we'll go ahead and slide that up, and we'll come back and talk about that towards the end of the video. But that is how an angle bisector is created. So let's collapse that folder, let's hide it, and let's move on to the next one, which is the median. So by definition, a median is a line formed that connects a triangle's vertex to the opposite side's midpoint. All right, so we're going to need some midpoints for this. So let's go ahead and construct those next. So we're going to go ahead and select midpoint, and you just have to hover over each segment, and it will plot the midpoint automatically. Hover over, click, and hover over and click. And we'll leave those midpoints there because at the end of the video, I'm going to show you why we want to keep them. But we are going to now go ahead and go back to our segment tool, which is tool number 3, and select segment. And so each median will start with vertex A. We'll start at A and we'll connect to the opposite midpoint. So in this case, BC's midpoint. There's my first median. My second one, let's go to angle B, click on it. It will connect to segment CA's midpoint. And lastly, angle C will connect to segment AB's. All right, just like we did it for the angle bisector, I'm going to click on each segment, 3 dots, move to expression, 3 dots, move to expression, and lastly, 3 dots, move to expression. We're going to slide these into our median folder, just like so. You'll see that line will tell you that it's correctly in the folder. Last thing we need to do is plot the point of concurrency here. So we'll go ahead and click that. And just like we've been doing, we'll click that, move over to expression list. Down here for label, let's type in the word median. All right, and let's slide that into our folder, and we are 2 down. All right, so the median has been completed. So we'll collapse that folder and hide it. So just as a summary so far, the goal of this is that we will get to look at all 3 points of concurrency at any point now. So if I highlight the angle bisector folder, you can now see all the work that we did for that. And the last thing here, same thing for median. Okay, let's talk about altitude now. This is the last one. And so by definition, this is a line form that connects a triangle's vertex and is perpendicular to the opposite side of the triangle. Now, in certain triangles, as I will show at the end of this, it may not connect to the opposite side. So that's something we're going to have to be very careful about. So we'll talk about that in a moment. But let's first go ahead and get this out of the way. So the way that we're actually going to do this is we're going to go up to the segment tool right here, and we are going to select perpendicular. This means we want to create a perpendicular line. Now there are two things you need to tell it. One is you have to first click which side length you want to be perpendicular to. So in this case, if we want to create the altitude for vertex A, we want to be perpendicular to segment BC. So I will click that. You will see that I haven't clicked yet. You will see it's going to ask me now where I actually want this to connect to. We want to choose vertex A. And there's our first altitude. We're going to do the same thing now. So if we want to angle B's altitude, we need to be perpendicular to CA. We'll connect it to vertex B. And last but not least, for angle C, we need to be perpendicular to segment BA, and we will connect to vertex C. So just like we've done in all the first ones, let's go ahead and move those into our expressions list. So click, click, and last but not least, click. And we'll put those into our altitude folder, just like so. We'll go ahead then and add that point of concurrency. Just like we've been doing in all the other examples, we're clicking on it. We're moving to expression list over here on the side. We're going to label this and we're going to write altitude and move it into our folder. And there we have it. And we can hide that and we're back to where we started. Now, before we go back to our example and wrap things up, I do want to make a quick mention about this last thing in parentheses where it says it may not connect to the opposite side. So that is going to occur whenever a triangle is obtuse, like it is right here, this 111-degree angle. So you don't have access or you don't have this triangle to look at, but you can certainly make your own and try this out yourself. So when we're creating this altitude, we're still going to use the perpendicular tool. So for example, if I want to connect again to vertex A, its opposite side is segment BC. But notice when I click BC and now I click on A, you can see that the segment goes well outside of the triangle. It does not connect to BC. So the reason that is because you'll see that, of course, to be 90 degrees is going to go down here. But you'll notice if I create this other line, this line right here, you will see that it still makes a 90-degree angle. It's just making it outside. Basically, you have to create an imaginary segment here that can, or sorry, an imaginary line that connects all the way outside, and you will see that intersection occurring. But that means if you created the point of concurrency here for the rest of these, watch what ends up happening. So for B, we would go here and here, and lastly for C, we would go here and here. You will note that that point of concurrency is actually well outside of the triangle if I zoom out. So this is another example where we will have the point of concurrency on the outside of the triangle in an obtuse triangle situation. We learned back in our circumcenter perpendicular bisector lesson that this can happen as well. This is the second time that we're going to see this occur. So just remember that if you have an obtuse triangle, the point of concurrency of our altitudes will occur outside of the triangle. Okay, we are now back to the original triangle we created. So just a couple reminders as we wrap up. So an angle bisector, the purpose of this point of concurrency is that this point of concurrency is going to be equidistant from each of the sides. Now that means if you were to draw a perpendicular line from this point to the segment, that those distances are going to be the same. Okay, and just to show you that, and again, this is a little bit difficult to show on here with the tools, so I just wanted to show you visually the confirmation that I ended up measuring actually each of these lengths to make it perpendicular to the other side, and you will see that all of them are 3.01. So the significance of the angle bisector is that it is the same distance from each side of this, from each of the sides of this triangle. Okay, now, let's talk about the other two real quickly before we wrap this video up. So for the median, the significance of this median is that this is our center of gravity of the triangle. So that if we actually wanted to balance this triangle equally and equally distribute the weight, you would need to balance it at this particular point, the point of concurrency of our medians. And then the last one, the orthocenter, or I should say the point of concurrency of altitudes, which is also known as its orthocenter, doesn't really have a particular direct application to it, but it is nonetheless one of the many, quote, centers of a triangle. So a triangle has 4 different center values. The one created from perpendicular bisectors, also known as its circumcenter. An angle bisector, which that is informally known as the incenter. The median's point of concurrency, which is known as the centroid. And lastly, the altitude's point of concurrency, which is called the orthocenter. But the goal of this lesson is that you want to be able to construct all of these using the tools here on Desmos and be able to identify the significance of each of these centers of a triangle.